Have you ever used a tool like ChatGPT, typed in a question, and just stared at the answer, wondering how on earth does it do that? It can feel like actual magic, right? But it's not. It's actually a really elegant process of math and logic. So today, we're going to pull back that curtain and show you exactly how an AI goes from your prompt to its answer. And to really get to the heart of it, we have to start with a puzzle. A puzzle that, honestly, seems like only a human could solve. How does an AI know which mole we're talking about when that one little word can mean so many different things? For us, telling these apart is a piece of cake. Our brains see biopsy and immediately think medical. We see shrew, we think of a little animal. It's all about context. But for a computer, the letters M-O-L-E are exactly the same every single time. So cracking this context puzzle, that's the absolute key to how modern AI works. So how do they do it? Well, the very first step is to kind of stop thinking about words as words. See, before an AI can understand our language, it has to translate everything into its own native tongue, which is math. This whole translation process kicks off with something called tokenization. It sounds fancy, but it's really just the act of chopping up a sentence into manageable little pieces, or tokens. Think of them like Lego bricks. They can be whole words, like the, or even just meaningful parts of words, like and unhappiness. A fantastic way to think about this is like exchanging currency when you travel. You can't spend dollars in a country that only uses euros, right? You have to make a trade. It's the exact same idea here. A computer can't spend text until it's been exchanged for its native currency, numbers. Every single one of those tokens gets its own unique number. But, just giving a word a number isn't nearly enough. We have to capture its meaning. And this is where the really cool part begins. This is where embeddings come in. I want you to picture a giant multi-dimensional map, a meaning map, where every single token is given its own precise set of coordinates. So on this map, words that mean similar things, like king and queen, are placed super close to each other. And related ideas, like king and palace, they're also nearby, but their coordinates show a different kind of connection. It's the distance and the direction between all these points that mathematically represents their relationship to each other. Now, here is the crucial leap forward. Older AI systems gave a word like bank just one single fixed location on the map. That was it. But modern AI, it creates what are called contextual embeddings. This means the coordinates for the word bank will actually change depending on whether we're talking about a riverbank or a money bank. So the big question is, how does it figure out that context? That question brings us to the single biggest breakthrough in all of modern AI. It's an architecture known as the transformer, and it completely, and I mean completely, changed the game. If you want to get a sense of just how huge this was, you only need to look at this one number. The original 2017 paper that introduced this idea has been cited by other researchers over 173,000 times. That's insane. It became the fundamental blueprint for pretty much every large language model we use today. So what was the big idea? At the heart of the transformer is this incredible mechanism called self-attention. And the revolutionary idea was this. It lets every single token in a sentence look at and directly measure its relationship with every other token in that same sentence, no matter how far apart they are. Okay, that might sound a little abstract, but I promise you, the best way to get it is with a simple analogy you already use every day. Just think about searching for something on YouTube. Now, what if we applied that same exact logic to the words inside a sentence? Okay, check this out. Every word sends out a query, which is basically it asking, hey, who here is relevant to me? It then compares that query to the key, think of it as the label or title, of every other word in the sentence. When it finds a really good match, it pulls in the value, which is the actual meaning of that other word. This is exactly how, in a sentence like, the animal didn't cross the street because it was too tired, the word it knows to pay attention to animal and not street. It's brilliant. So now the AI can understand context by weighing all these relationships between words. Awesome. But how does it actually write a response back to you? Well, the answer is kind of surprisingly simple. It does it one word at a time. It all happens in this incredibly fast loop. The model looks at your prompt plus everything it's already written. Then it predicts this huge list of probabilities for what the very next token should be. It picks one, adds it to the sentence, and then the whole loop starts over again, but this time with a new word included. It genuinely has no idea what it's going to write 3 words from now.
So you might be wondering, why doesn't it give the same exact answer every single time? That's where a little setting called temperature comes in. Think of it like an ice cream shop. If the temperature is set to 0, the AI plays it safe. It's always going to pick the most popular flavor, vanilla. But if you turn that temperature up, it gets a little more adventurous. It might just pick a less common but maybe more interesting option, like spicy jalapeno chocolate. This lets it blend creativity with making sense. So all of this leads us to a really big debate. If the AI is just predicting the next word over and over, isn't that just a really, really fancy version of the autocomplete you see on your phone? Well, it's complicated. I think this quote from a researcher named Barak Shoshani just nails the best counterargument. Yeah, it's predicting the next word. But to do that well and to do it consistently across millions of different topics, the model has to build this unbelievably sophisticated internal map of grammar, facts, and even abstract concepts. It's like saying a chess grandmaster just predicts the next move. Sure, but to do that requires an incredibly deep model of strategy.
And the proof is in the pudding, right? These systems can do things that go way beyond simple pattern matching. I mean, they're scoring highly on tests specifically designed to be Google-proof. They're coming up with novel combinations of ideas, and they can even follow multiple steps of logic to figure out a problem. So let's bring it all the way back to our original question. Did we solve the mole problem? Absolutely. By turning words into coordinates on that giant meaning map, and then using that powerful attention mechanism to figure out the relationships between all the words. The AI can figure out from biopsy or carbon dioxide exactly which mole we're talking about. And that leaves us with one final and really fascinating question to chew on. The experts themselves are totally divided on whether these systems truly understand anything, or if it's all just incredibly sophisticated mimicry. But if an AI can reason, if it can create new ideas, and it can communicate effectively, does the difference even matter? That's something to think about.